Hi everyone, in this video I am going to teach you how to find the domain of a rational function that has a square root in the denominator. Okay, so I also have different videos about finding the domain of a specific function, so please look for that in my YouTube channel. The playlist is about a domain of a function or domain of functions. Let's begin with this first example. So since we have a rational function, there's a rational function and a square root, and there's a square root in the denominator, there are two restrictions. What are those two restrictions? Number one is that the denominator cannot be equal to 0. The second is, since there is a square root in the denominator, that means the other restriction is that x plus 4 cannot be equal to a negative number. So it cannot be equal to 0, and it cannot be equal also to a negative number, which means that it can only be positive. Okay, so that means to set up the problem, or to set up how to solve this problem, it's going to be x plus 4 is greater than 0. Okay, that's what we want. What we want a positive number. So we will subtract 4 on both sides. We cross that out. That means x is greater than negative 4. So all the numbers greater than negative 4 can replace x. So to convert that into interval notation, we will start with negative 4, and we will use an open parenthesis, which means it's a non-inclusive inequality. Negative 4 is not part of the domain, okay, up to positive infinity. Okay, next, let's go to the second example. Here we have 3 minus 2x. So that means 3 minus 2x is greater than 0. So next step is we will subtract 2x on both sides, or subtract 3 on both sides. This is going to be negative 2x is greater than negative 3. Then we will divide both sides by negative 2. I cross that out. This will be x is less than 3 over 2. Okay, the reason why it switched from greater than to less than is because we divided a negative number. So you always do that every time you divide a negative number or multiply a negative number in an inequality. That inequality symbol will switch. So since this is less than, that means we will start with negative infinity up to 3 over 2. So that will be our domain for number 2. Let's go to the third example. We have here 3x squared minus 3 is greater than 0. So we add 3 on both sides. This will be 3x squared is greater than 3. And then divided by 3 on both sides. This will be x squared is greater than 1. So find the square root of 1. That will be negative 1 and positive 1, or negative positive 1, or positive negative 1. Okay, so we have two answers here, positive 1 and negative 1, and it's greater than. Okay, so just to give you an illustration on how we convert this into an inequality or in interval notation. So let me draw this number line and locate that positive 1 and negative 1. So here we are thinking about what region are we going to exclude, or what region are we going to include. Okay, so because there are three regions here that we're talking about. Okay, the region from negative 1 to positive 1, the region from negative infinity to negative 1, and the region from positive 1 to negative infinity. Let's check. Again, we do not want the denominator be equal to 0, and also it cannot be a negative number. Let's try 0. So 0 squared is equal to 0 times 3. 0 minus 3 is equal to negative 3. So we do not want this 0, which means we will exclude this region right here. So that means our domain, okay, will be from negative infinity to negative 1. Okay, negative 1 is not included there. Union of positive 1 to positive infinity. Okay, let's go to the, I think this is the last example for this particular topic. Here we have 50 minus 2x squared is greater than 0. So subtract 50 on both sides. This will be negative 2x squared is greater than negative 50. Then divided by negative 2 on both sides. And of course, you expect, or you know what will happen here. That symbol will switch from greater than to less than 25. And then find the square root of both sides. This will be x is less than positive negative 5. Okay? So again, let me give you an illustration. To find the region we will include here, we have negative 5 and we also have positive 5. Are we going to include the region of the numbers from negative 5 to positive 5, or the numbers from negative infinity to that negative 5, or from 5 to positive infinity? Let's check. Let's try 0 again because that's the easiest. So replace that x by 0, that's 0 square times negative 2 is negative 2. 50 minus 0, that's what we want, it's positive. So that means we will include the region from negative 5 to positive 5. Let's try 6. Let's say it's 6. So 6 square, it's 36, right? Times negative 2 is negative 72. Negative 72. Is that right? Okay. And then 50 minus 72 is obviously a negative number. So we do not want this region. If we will replace that by negative 6, I think the answer will also be the same. So we do not want that region. So that means the domain will be from negative 5 to positive 5. Okay, but negative 5 and 5 are not included. Okay, let me just emphasize that. So let me summarize what we have here in 3 and 4. It's very important to understand that if you have a greater than symbol, positive, and you have two answers, one is positive or the other one is negative, expect an answer like this: negative infinity to positive 1 to negative 1, rather, union of positive 1 to positive infinity. Now, if we're dealing with the less than symbol, expect that the answer will be something like this, like a coordinate in the Cartesian plane. Okay, so that's it for this video. I will please look at the other videos also from my playlist. It's about finding the domain of a function. Okay, so thank you for watching and have a great day.